Today we are going to start with our next topic, that is liquid state. In our previous class we had already completed with the solid state, and in our today's class we are going to start with the liquid state. So let us see first of all that what all examples are included in liquid state. We know water, milk, oil, kerosene, petrol, alcohol are all the examples of liquid. Now we know this thing that liquids have a fixed volume, but do they have a fixed shape? No. If you put them in this type of container, they will acquire the shape of this container. If you put them in this kind of container, they will acquire the shape of this container. They cannot be compressed after a certain limit. If you try to compress the liquids, they will have a certain point after which they cannot be compressed. This becomes an important point. Now they have moderate to high density, means they do not have a low density, they have a moderate to high density. Yesterday only I told you the density ratio, that the solids have highest density, then liquid, and then gases. So liquids lie in between. They have lesser density than solids. They do not fill the container completely. They flow easily, means they have fluidity. Now how do they not fill the container completely? If you fill a liquid here only, so it will be till here, it cannot cover this upper surface. Next, they can flow easily. Liquids are fluids, we know this thing. Now when we put liquid, that is a water, in different shape of container, the shape of liquid also changes. But when we observe carefully, then no volume of liquid will change. If you take 1 liter of water and you put in different types of containers, you will find that this 1 liter of water will always remain 1 liter of water, no matter if the shape acquires like this or this. So this is about the liquid state. Now let us talk about the next state, that is the gaseous state. In gaseous state, first of all, let us see the examples, including air, oxygen, hydrogen, carbon dioxide, steam are the common examples of gaseous state. Now let us see the properties of gases. See, the properties of gases are that they do not have any fixed shape as well as volume. So this is a very important thing. Neither is a fixed shape, neither is a fixed volume also, because if you take this container and if you fill this, and similarly if you take this container and you try to fill this, both of them will be filling completely. It means that the volume is not fixed. In any container, the volume of gas can vary and the shape can also vary. They have a negligible amount of force of attraction between them, because the particles force of attraction is less. Because of that only the particles are far apart, and because of that they do not have a fixed shape as well as a fixed volume. Now let us talk about the energy status of states of matter. This is very important. Now you should know that we have basically two kinds of energies. What are those two kind of energies? We know that energies are either kinetic energy, either these are potential energy. Now what is the meaning of kinetic energy and what is the meaning of potential energy? When the particles are in motion, during that time when they are moving, at that time the energy that will be present in the particles is the kinetic energy, and when particles are at rest, during rest the energy which will be present inside them is the potential energy. So you should know that gases have maximum velocity because the particles are far apart and the forces of attraction are also very less, and due to this reason the particles continuously tend to move, and because of that the velocity is high, and because velocity is high means these are in motion. That's why we can say that they have maximum kinetic energy and minimum potential energy. There is opposite thing for solids, because solid the particles are very tightly packed. Because of that they cannot move, and since they are not moving they will be at rest, and since they will be at rest, we can say easily that here we will be having maximum potential energy and minimum kinetic energy. Now the liquids can be at rest also, and liquids can be in the motion also where they are moving. So because of that we say that they have both kinetic energy and potential energy. Now there are some formulas that you have to learn of kinetic energy. This you learn in your physics, that kinetic energy is your half mv square, or it is 3 by 2 kbt. Now here we should know that kinetic energy has a dependence on velocity as well as a dependence on temperature. You can see from this formula as well as from this formula that the kinetic energy has a dependence on velocity as well as kinetic energy has a dependence on temperature. What does it show? That as the velocity of the particles will increase, it will lead to increasing kinetic energy, and as we are heating up the things, the temperature is increasing, temperature will increase, so the kinetic energy will also increase. Why will it increase? Because velocity is increasing. So these are the two concepts which you should learn. So this is the energy status of matters, various states of matters. Now let us talk about the temperature and energetics. Let us see what they are saying in temperature conversion. Now first of all, what is temperature? Temperature is the measure of degree of hotness or coldness of a body, means how hot or cold. Even we are taking coldness also as a measure, how hot or how cold a particular body is, that is its temperature. Now there are various scales of temperature. We have Celsius scale, Fahrenheit scale, as well as the Kelvin scale. These are the three major scales of temperature through which we can measure the temperature of different objects. Now we will talk about Celsius scale, Fahrenheit scale and Kelvin scale separately. First of all, let us talk about the Celsius scale. Celsius scale, now know that in any type of temperature scale there will be one lower limit and there will be one upper limit. Lower limit says that this is the minimum temperature. Below this, the temperature cannot go on that scale. And upper limit means this is the maximum range of temperature. Above this, the scale cannot measure the temperature. So in Celsius scale, we have the lower limit as 0 degrees Celsius and the upper limit is 100 degrees Celsius. This degree Celsius is what? This degree Celsius is unit. Second, Kelvin. In Kelvin, the lower limit is 273 Kelvin. Now this is very important thing. Here 273 Kelvin is there and the upper limit is 373 Kelvin. Now this Kelvin is again unit. You should know that these two are equal, means 0 degrees Celsius is only 273 Kelvin and 100 degrees Celsius is only 373 Kelvin. There is one Fahrenheit scale also. Fahrenheit scale says that the lower limit is 32 Fahrenheit and upper limit is 212 Fahrenheit. This Fahrenheit is what? This is again the unit of this Fahrenheit scale. So these are the three different types of scales. Now let us talk about the formula. This is a very important and very basic formula which can be used to calculate all the examples of temperature calculation. What does this formula say? If we have to calculate the particular thing, like whatever is the given temperature, if we have to find out, then what is the formula to calculate that? Whatever is the given temperature, you have to take that temperature, then you have to subtract this from lower limit upon, you will write again upper limit minus the lower limit. Now there is one very important thing. The importance of this formula and the specialty of this formula is that this formula cannot be used in a single way. In a one go we can never ever use this formula. This formula, which has been even mentioned over here, this formula is always used in a reference mode, which says that we use two scales here. There is one more scale, that is scale 2. For scale 2 also we will have a temperature 2, we will have a lower limit 2, we will have a upper limit 2 and we have a lower limit 2. Now what do we do is that either this temperature is unknown to us or this temperature is unknown to us. If this temperature is unknown, what we are going to do is we are going to put this quantity and these two quantities, we are going to shift them over there, means we'll bring them over there in this formula. So how we are going to do? Let us take one very easy example to understand this. Now see how it will be that you will be having two scales. Suppose here you will be having scale 1 and here you will be having scale 2. Now scale 1 has a temperature, suppose T1, that is 40 units, and scale 2, the same temperature. You have to find out that what will be that temperature on the other scale, but some things will be given. Like scale 1, the lower limit will be given, suppose it is 0 and upper limit is 200 what units, because we do not know what type of scale it is. It is not a Celsius or Fahrenheit scale. Similarly for scale 2 we will be having the lower limit. Suppose here the lower limit is 30 unit and the upper limit is 100 unit. Now what do we need to do? We need to equalize these two, which means we'll write here the temperature minus lower limit upon upper limit minus lower limit. Now this is T1, this is again 1, this is 1 and this is also 1, and here we are going to write T2 minus lower limit 2 upon upper limit 2 minus lower limit 2. This is the basic formula. This step at least you have to learn by heart. Now after learning this step, what we are going to do is, now we are going to substitute the values. What is T1? T1 is given to us 40 units. We are going to put that minus lower limit of this scale is 0. upon upper limit is 200 minus lower limit is 0. Equalize it over here. Here we have T2. T2 is, we have to find out that it is x minus lower limit is 30 upon upper limit is 100 minus lower limit 30. Solve this. What do you get here? Here you get 40 upon 200, and here you get x minus 30 upon 70, which shows that after that what you need to do is you have to again solve this further. You will send this 70 over there only, like this, and here x minus 30. Now cut this to solve it easy. It is 14 over here. 14 is equals to x minus 30. So x equals to 14 plus 30, which means x is equals to 44 units. Means if on one scale we have the 40 units as a temperature, this temperature is equivalent to 44 units on the other temperature, provided these are the conditions which are given over here. These conditions will be always given in your question. Now let us see some examples over here. Now the question given is that derive the formula relation between the three scales of temperature. This is a very important question. It is generally asked in the examinations. Now you have to do nothing here. You have to do the same thing which you can do yourself also. What you have to do is here that you have to put that same thing, that temperature minus lower limit upon upper limit minus lower limit. You have these three things here: temperature, degree Celsius, degree Kelvin and degree Fahrenheit. You have to put the lower limits and the upper limits of these Celsius scale, Kelvin scale and the Fahrenheit scale. Here it is not 273, it is 212. Solving it, we get this, and finally this will be this only. If you solve this, you get this type of formula: degree Celsius upon 100 equal to degree Kelvin, only Kelvin, minus 273 upon 100 equal to Fahrenheit minus 32 upon 80. This is the relation that you can either learn or in the examinations it can be asked to derive. So we are going to do till here only today. That's all for the day, students. Thank you and have a nice day.